Why is the universe expanding? This phenomenon was first noticed by Edwin Hubble.
He called it redshift because things appear to be more red as they move away from the observer. There are two major forces in universal expansion, both of which we know very little about. First is dark energy. We don't know much about this force, but what we do know is that it causes the universe to expand and that there's a lot of it.
68% of the universe, in fact.
However, it's very important to look at how a dark energy causes the universe to expand. It does not make everything move away from one point in space.
It's like debris on the edge of an explosion. Instead, it causes every single particle to move away from every other.
However, there is another force holding us all together. Because I don't know about you, but my particles haven't floated off into space. This force is gravity. But more than 80% of gravity might be caused by a mysterious source known as dark matter. But how does gravity work? Well, if we go back to the 17th century and look at a fellow named
Sir Isaac Newton, then just Isaac, said,
"Hey, I think all matter is attracted to all other matter,"
and then gave us an equation with which to calculate that force of attraction,
where gravity was proportional to mass, and he called that gravity. However, centuries later, astronomer
Fritz Zwicky noticed that there was not enough mass in some large-scale galaxies to account for the amount of gravity holding those systems together.
This missing mass was dubbed dark matter. But if dark matter is holding our universe together, why is it still expanding? Well, scientists have tried to calculate this using
omega. Omega is a constant based upon
the relationship between matter, dark matter, and energy. If omega exceeds 1, the universe expands forever and ever. If omega equals 1, the universe is static. It's not. And if omega is less than 1, the universe collapses back on itself, and we have Big Bang number 2. Right now, scientists have formulated omega and found it to be equal to 0.3. So we can say for certain that the universe is expanding, probably very rapidly. However, the story is not over yet. If these dark forces do exist, they are very peculiar, because scientists have found that dark matter does not interact with light in any way, defying the properties of normal matter in this and many other ways. And dark energy is just another in a long line of explanations for universal expansion. Because of this, other scientists have come to propose
wildly different explanations for dark matter and energy,
many of which are potentially valid. So this case of universal expansion is still open for business, waiting for the next great astrophysicist to come along and solve this conundrum centuries in the making.